technology, from Aerojet, in ordnance, in electronics, and in rocket propulsion, providing significant contributions for many of today's major aerospace programs. From volume production of medium caliber ammunition to sensing systems for airborne surveillance missions, to propulsion used on missiles around the world. Aerojet has been a major innovator in the American ordnance business for 30 years and is the only American company with the capability to provide total package requirements, from design through development, testing, and high-volume production of complete munition systems. Aerojet is the leading United States producer of 30mm rounds for the GAU 8A Gatling-type gun on the Air Force A-10 aircraft. This ammunition utilizes a heavy metal penetrator, which is extremely effective against tanks. This same technology is also being applied to 25mm rounds, being developed by Aerojet for use with aircraft or ground vehicles. Our ordnance technology extends beyond ammunition into a family of scatterable mine systems and other ordnance products high on the priority list for national defense. Our ordnance and electronics technology work together in a new system under development for the United States Army called SATARM. SATARM integrates a microwave sensor with a self-forging fragment warhead to provide the Army with a fire-and-forget all-weather artillery weapon. SATARM requires no in-flight guidance or command control assist and has proven to be highly effective in test firings. Aerojet's sophisticated electronic technology has been utilized to develop Air-Eye, a system designed for use by the United States Coast Guard aboard jet aircraft for search and rescue, for fishing violation detection, immigration control, environmental sensing, to fight illegal drug traffic, and shipping monitoring. Aerojet devised a multi-sensor system for Air-Eye, which includes radar, infrared and ultraviolet, and television detectors, integrated with a digital sensor management system. One operator can manage an effective search, even under adverse weather conditions. Aerojet's rocket propulsion technology has contributed to aerospace achievements since World War II, with both solid propellant and liquid propellant systems. Our engines have played key roles in America's manned space program, on Gemini, Apollo.
I was strolling on the moon one day in the merry, merry month of December.
And the Space Shuttle. On the Space Shuttle, Aerojet engines provide the power to place the spacecraft into proper orbit, and then give the final burst of power to enable the shuttle to come home. Aerojet engines provided the same function for the historic Apollo moon landing program.
Look at the size of that biggie. It is a biggie, isn't it? Okay, we're headed that way. You get the tongues, John?
Titan launch vehicles with power from Aerojet propelled the Viking and Voyager spacecraft, which gathered important information on the planets Jupiter, Saturn, and Mars. Satellites lifted into space by the Japanese N2 launch vehicles depend on Aerojet's second stage propulsion system. Our rocket motors provide power for missiles such as Titan. Minuteman, MX, and Sidewinder for the U.S. Air Force. Polaris for both the United States Navy and the Royal Navy of Britain. Skyflash for the British Air Force. Standard Missile for the U.S. Navy. And Harpoon for both the United States Navy and the Royal Navy of Britain. And the improved Hawk, used by many nations. An automated, solid propellant, rocket motor production system at Aerojet is a model for the industry. This facility includes a microprocessor-controlled operation for loading propellant, an automated X-ray inspection system, a paint robot, and a unique monorail system which automatically moves the rocket motors through the production facility, providing ultra-high quality while producing large quantities of tactical missile motors. Aerojet's reputation as a manufacturer of quality solid rocket motors is reflected by a reliability rate of more than 99.98% in thousands of field firings. In the last decade, Aerojet has applied its rocket propellant expertise to developing a new family of plastic bonded explosives, or PBXs. PBX technology is similar to that of solid propellant in composition and production. PBX is very safe and easy to handle and store compared to conventional explosives. It can be used for a variety of applications, such as warheads and gun-launched projectiles. Another application for this high-energy product is Quick Strike, the U.S. Navy's largest and most powerful shallow-water mine, which is manufactured by Aerojet. Aerojet offers these products and services through 5 separate companies in its Aerospace and Defense Products Group. Aerojet Electrosystems Company, Aerojet Ordnance Company, Aerojet Liquid Rocket Company, Aerojet Strategic Propulsion Company, and Aerojet Tactical Systems Company. Aerojet, a subsidiary of the General Tire and Rubber Company, was founded in 1942 by Dr. Theodore von Karman and a few associates at the California Institute of Technology. Dr. von Karman, the Hungarian-born, world-famous aerodynamicist and first recipient of the United States National Medal of Science, developed a system for jet assist takeoff units for military aircraft. These products, called JATO, were widely used by the military starting with World War II and formed the basis for much of the rocket technology in use today around the world. Technology from Aerojet, in ordnance, in electronics, and in rocket propulsion, serving the aerospace industry with creativity and reliability for more than 4 decades.
Large-scale integration, LSI, the linking together of thousands of transistors on a single tiny silicon chip. It's a concept that's changed the future, made possible things considered impossible only a decade ago. Today, LSI is everywhere.
He's even
After the
although he refused.
You have a call on line 2.
This explosion of new applications has resulted in an ever-increasing demand for circuits that will do more, be more dependable and more economical, and use less power and less space. Circuits that are customized to specific performance requirements. And that is why custom MOS LSI is recognized as the most effective way to meet the growing demands on integrated circuits. You see, custom integrated circuits offer a number of benefits not available with standard logic. They save money. One custom chip can replace expensive electromechanical devices, discrete logic components, or inefficient general-purpose large-scale integrated circuits. With a single chip, production costs can be reduced. Inventory costs come down. Space, location, and power requirements are minimized as well. Custom circuits provide greater reliability.